Alright guys, we took a short break, but we're finally back and ready to share my new project called Web3 Skyrim Market. And I think it's better you see it for yourself. We find ourselves in a medieval market. Let's imagine we've been grinding all day, killing monsters in the wilderness, and for each monster we've got some crystals. If I open my menu, I can see some crystals right here. These crystals are an in-game currency that we've created on PlayFab. With this Web2 currency we could, for example, buy some basic items here, like potions, which really don't have a great in-game value. But what if you want to buy some new outfits, for example, for our character? Maybe those outfits could actually have a real in-game value and even outside of it. So here is where Web3 comes in. We can go to the outfit shop to buy a new outfit. But we need to have some new currency called Septim, the Skyrim currency, which in this case is an ERC20 token. So to get some, we can go to the last shop here, the exchange, and trade our crystals for Septim. So, for example, I'm gonna get 4. I'm gonna trade, confirming my message in MetaMask, and the transaction is successful. If we now open our menu, we'll see that the Septim balance has increased to 8, and we don't have no more crystals. So we can go to the shop again and buy one. I'm gonna buy the green outfit. So I'm confirming the message again on MetaMask, and the transaction is successful. I just minted an outfit, an NFT outfit, using an ERC20 token. And that's not all, because if we now go to the menu, you'll see that we can actually apply the NFT outfit to our character. Now I just applied and I'm green, and I can also go back to default and I'm blue. So, okay, as you see, we're marrying Web2 and Web3 gaming here. We used PlayFab as a Web2 backend to handle all the data that has no potential value for the user, and we applied Web3 to give real value to items that might deserve it, like these outfits. And thanks to Moralis, I could do this with almost no effort, and because it is cross-chain, I chose to run all these on Cronos because of its speed and sustainability. And by the way, if you still don't know, the biggest Metaverse Hackathon registration deadline closes in less than 2 weeks, so hurry up, go to moralis.io Cronos Hackathon and register down here to save you a spot and be able to compete for an amazing prize pool of 100k. 100k, guys. So do that and prepare to start.
What's up everyone, this is David from Barcelona and I work as a Unity content creator at Moralis. I'm also into music, bass here and drums. I enjoy cycling and practicing karate. Cheers!
And as I said, thanks to Moralis, I could do the Web3 integration to my game very easily thanks to the workflow that provides. So for example, it is very easy to authenticate to Web3 using Moralis in any new project, for example, the game that we're gonna see. And also it has the ability to sync historic and real-time events from any contract and any chain, in this case Cronos, but we could do also with any EVM compatible. And also it has APIs, a specific API for NFTs, so the Solana API, and even also Elrond, which is coming. And it has some SDKs. I've used the Unity 1, but also has SDKs for web development platforms. And now we're focusing a lot on our backend SDKs, the Node.js and .NET, and Python, and also Java is coming soon, and much more. We're also looking to integrate many gaming backend platforms like Azure PlayFab very soon. And before diving deep into the project, let's check very fast the structure that the video will follow. First, we're going to set up Moralis and then PlayFab. So we have the Web3 and the Web2 integration. Then we will deploy 3 smart contracts, one standard contract, then an ERC20, and finally an ERC721. We will use Hardhat for that. Then we will deep dive into the exchange shop and learn how to convert PlayFab currency to ERC20 token. Then we will go to the outfit shop and learn how to buy NFT outfits with these ERC20 tokens that we just converted from PlayFab currency. Finally, we will apply the bought NFT outfit to change the look of the character. All right, so the first thing that we need to do is to fill up the Moralis Web3 setup. So to do that, go to moralis.io, click on login, create an account if you don't have one. I already have one, so I'm just gonna log in. And here, create a new dapp. Select testnet and select Cronos. We're gonna do this on Cronos. So proceed, select your region, your dapp name, test dapp for example, and after some seconds we should have our dapp created here. Gonna refresh, and here it is. So click on settings and copy the dapp URL, go back to Unity and copy the application ID. Perfect, that's it. Okay, so the next thing that we need to do is to create a new PlayFab account. So go to developer.playfab.com and create a new free account here. I already have one, so I'm going to click on login and fill in my account, login, and we will find ourselves in this page. Now click on the three dots here and click on new title. Name this, for example, Web3 Skyrim. No need to website URL, no logo, just create title. And perfect. Now what we're doing here is creating a new backend that we'll use in Unity. So now what we need to do is go back to Unity. And because the PlayFab SDK is already installed in this project, you can go to Window, PlayFab, Editor Extensions, and what we want to do is to click here on login and just log in with your just created account. That's what I'm doing now. Typing the password. I think. Okay, so now we're logging in, and what we'll do is go to settings, and here you need to select your new, this is the studio, and automatically make sure that you have the title ID as the one that you just created, okay? And the game studio, this studio is just, if you go here, and PlayFab. This is because I already created a new game studio here before creating my title. So if you didn't do that, just before creating the title, create a new studio. Finally, go back to Unity and make sure that we have selected Unity Web Request here, and also go to API and make sure that Enable Server API is enabled. And let's go through this. I think everything is good. Okay, so yeah, your title ID here, Unity Web Request, and Enable Server API needs to be enabled. And that's it for the Moralis setup and the PlayFab setup. Okay, so now that that's done, I just open game scene, which is under assets, project, and scenes. And I want to show you what happens when we authenticate. Now we'll be able to authenticate through Moralis. And once we authenticate, scanning the QR code with my MetaMask, signing, will automatically log into PlayFab. Okay, so as you see, there's this message right here, set read-only user data successful. So if I go to PlayFab and I go to players, I click on search, and this is the unique ID. So I just logged in, that's good. And under player data, I have my wallet address and the chain ID, which is Cronos testnet. So how that happened is that here under singletons, we have the PlayFab server simulator. So I'm gonna open this, and we'll see that after authenticating with Moralis, you'll see, So when we have authenticated with Moralis, we set the player user data using this PlayFab server API request. So now in this project, we're doing this in this way. But if you are a game studio, game developer studio watching this, you need to know that in Moralis we are developing a full integration with PlayFab. So all this, instead of doing it from the client, you will do it through Azure functions, and the PlayFab backend and the full integration will take care of this automatically when using the authentication kit. So yeah, just wanted you guys to know this. And we're gonna be making videos about this very, very soon. Okay, now let's go to the next part. Okay, so I just opened the scene right here, which is under Assets Project Scenes, okay, the game scene. And here under Singletons, on smart contracts, if we go to the inspector, we find all the data for the smart contracts that we will need to fill. So we will be deploying our Septing ERC20 contract, Outfit ERC721 contract, and a standard contract, which is the game contract that will take care of interacting with these two. So Unity will only be interacting with the game contract. It's like a game manager, but for smart contracts. So what we need to do now is go to Visual Studio Code. Okay, so I just created an empty folder in my desktop, and I went to Visual Studio and I opened it by clicking here on Open Folder. So I have it right here. I also opened my instructions, which are in Unity under Assets, Smart Contracts, Hard Hat. Here are the instructions, and you'll see that we'll be using these files later. But we'll just open it so you have it here and we can follow. So first of all, what we'll do is install Hard Hat. So open the console and just paste this here. So I'm going to be pausing this because some of these instructions take a while. Great, that's done. And now we'll be running the second one. I can type this one. And what we will do here is create a new Hard Hat project, a sample project. I want to create a JavaScript one, so I click on Enter, Enter again, and again Enter. Perfect. So now, as you see here, it says that I need to install this. So this is my next instruction, installing this dependency called Toolbox. So again, I'm pausing this. Great, now it's time to install Chai Matchers. Copy this, paste it, and enter. This one is fast. Now I'm going to install the OpenZeppelin contracts, which will let me use OpenZeppelin contracts in Hard Hat. This one is important too. And finally, we're going to install Etherscan. And then we will install the plugin over Etherscan, which is specific for Cronos. It's Chronoscan. And will let us verify when we deploy the contract to Chronoscan, so we can see it there. Perfect. So now we have all this. What we need to do is go to Unity, and we'll need to copy all these files, okay? Copy these files and replace it on this project. Okay, so here we have the two folders, the one in Visual Studio Code and the one that I have in Unity. So what I want to do now is copy these files right here that are already prepared to the new project that I just created. So, well, but to start, we're gonna delete some automatically created contracts that this happened when we created the Hard Hat project. So under contracts, I deleted this, and under test, I will also delete this lock contract. Now it's good. What I'll do now is under contracts, I'm gonna copy the game contract, the outfit contract, and the Septim contract, leaving outside the meta ones. So copy this, go to contracts and paste it. Perfect. Now we'll do the same with the deploy.js. We'll copy this under scripts, and under test also we're gonna copy the test game contract and paste it right here. And finally, what I want to copy, which is very important, is the hardhat.config.js, and and I will also copy the instructions. Perfect. So copy this and paste it right here. So now if I go to Visual Studio Code, I should have the contracts right here, the deploy script, and the hardhat.config.js. So let's take a look at the contracts very fast. As you see, the game contract is, as I said, is like the game manager of contracts, because when it is constructed, we're passing the addresses of these two contracts right here. So then in Unity, we will be only calling these functions right here. So for example, to get septim balance, we're going to call this one, and to add and to remove the septim balance, we're going to be calling these ones. And as you see, when we call this, we're calling functions from inside this contract right here. So this is a very nice setup. Thanks to my colleague Sam for the idea. And for example, also on by outfit, we'll be calling this, which is calling both functions from the septim, here, get septim balance, and also from the outfit one. So as you see, it is pretty simple, the game contract. And if we go to see the outfit contract, it's a very simple ERC721, which is just minting the new NFT, and the septim, which is an ERC20, which is also very simple, adding balance or minting new tokens to the player, or removing, burning tokens from the balance. So yeah, that's basically it. If we now go to the instructions, it says that we need to fill some keys in hardhat.config.js, which is here. And as you see, here we need to fill the private key of our wallet and also the Chronoscan API key. So we can start by this one. Go to the browser, go to chronoscan.com and create an account if you don't have one. I already have one, so just I'm gonna log in. You can create an account here. And logging in, and under my user in API keys, you can create a new API key by just clicking on add. So I already have one. I'm gonna copy this, go back to Visual Studio Code and paste it here. This is needed for the contracts that we will be deploying to be verified in Chronoscan. Perfect. So this one is already okay. So this is the Chronos RPC node URL, which is okay. You don't need to modify this. And before going for the wallet private key, go to your browser, and we'll be importing the Cronos testnet to our MetaMask first. If you haven't done already, we'll be doing it now. So first of all, connect your wallet, select your account, wherever you have here, and search for Cronos testnet. Oh, you need to enable testnets. So click on add to MetaMask. And because I already have it, no messages going on here, but you will just need to accept it. And you'll have the Cronos testnet imported in your MetaMask. But now what we also need is some T-Crow here. Because we will need to deploy this, we'll spend some T-Crow. So go to chronos.org, faucet, and here copy your MetaMask address and paste it under here. We're not a robot. And we're getting Crow. And Cronos is very, very fast. You'll see that if I now open my MetaMask, I already have 50 more T-Crow. So that's perfect. That's what we need to deploy the contract then. But also, what we'll need to do at some point is go to chainlist.wtf, okay, make sure this is the right address, and go to connect wallet. And here you will be able to do the same for your MetaMask mobile, okay? We'll also need to have some T-Crow and the Cronos testnet imported in our MetaMask mobile, because we will be signing to the game. We'll need to have this, and we'll spend some T-Crow for the transactions. So scan this with your MetaMask mobile and import the testnet, and also add some T-Crow using the faucet. Okay, we can close this and now go back for what we need to do, which is here on the three dots. Go to account details, export private key, type your password here, and never, even if it's a testnet, never give your private key to anybody. So I won't show you, but just type your MetaMask password here, copy the private key that will show up, and paste it right here under private key. Great, so I just did that, and now I'm in the deploy.js. So this is the script that will be running now to deploy all the contracts. So as you see, first we deploy the Septim contract, then we deploy the outfit contract, and with the deployed addresses, we then deploy the game contract, passing the addresses as parameters. As you see, we said that before. Here I need the two contracts addresses. So that's a very nice setup right here. And after this, I'm also gonna log out the game contract API, because I will need the game contract API in Unity. And after this, I will just verify the game contract. So I think we can go ahead, go to instructions, and first open the console, and I'm gonna first clean the project. npx hardhat clean. Now npx hardhat compile. This should be okay, perfect. And now I'm gonna copy the last instruction, which is running the deploy.js under the Cronos testnet. So paste this and enter. And now we'll wait a bit, because this takes a while. We need to deploy 3 contracts. Nice. So here we have all the contracts deployed. We have the addresses and the game contract API. So let's copy this, Septim address, go to Unity, and under singleton smart contracts, here is where we need to paste this. So paste the Septim address right here. Do the same for the outfit contract address. The same for the game contract address. And finally, the API. Make sure you copy this correctly, okay? And paste it like here. Save it. And if we go to smart contracts, we see that this is a singleton. So we'll be able to access this data from anywhere in the game. Okay, so that's it for the configuration and the deployment of the smart contracts. All right, so now we will learn how to get some crystals from PlayFab and then trade it for some Septim, the ERC20 token. So first thing we need to do is go to PlayFab, and under economy, currency, we will add a new currency. We will call this crystal, and the currency code is important, will be CR. We can leave this like that and click on save currency. Now with this CR code, we can copy it, go to Unity, and paste it under here. So if we open again the PlayFab server simulator, we'll see that this is a singleton. So this means that we'll be able to access the currency code from other scripts. So what script do you think that use this currency code? So if we go to game state machine, okay, I changed the game manager name to now I'm calling it game state machine, if you guys have watched some of my previous videos. And all these are states. So I think I'm going to show you how this works a bit. This doesn't exactly relate to getting the currency. But I think it's important you guys know how the game works, okay? So I'm opening my MetaMask now. It's taking a while, but at some point, I guess this will pop up. Okay, perfect. Now I'm scanning. And if I sign, perfect. Okay, so as you guys see, this is a game, a state machine. So now I'm into exploring. I just authenticated. And if, for example, I go to the shop, I'm into the shop area, okay? So this happens if you go to town and you go to outfit shop, go to scene, you'll see that. Make sure you are in 3D mode. Go here. Let's go to the exchange where I am. You'll see that this has some colliders, and this shop collider triggers, well, let's open it. It triggers an action, okay, passing the shop type when the player enters. So this exchange is shop time exchange, outfit shop is outfit, and item shop, which are not, we are not using this for this project. But this is just all triggering some event when the player comes in, okay? So what happens is that the game state machine, let's open this. As you see, listens to this event, okay, on player entered, and here on player entered basically changes the state to the shop area and saves what current shop are we in. So in this case, we're into the exchange. So when the player is inside, we go to shop area. So if we go to in shop area state, which is this one, when it enables, of course we know that we are on the exchange one because we just saved it. So we display all this information right here, and we are in this state right now. So if I press enter, now I'm gonna pass to the shopping state. And inside this shopping state, I have some shops right here. Okay, I have the exchange, the outfit shop, and the item shop. And if I open shopping state, we'll see that also checking in what shop type are we in, I'm gonna activate these different shops. So if I go to exchange and I see the exchange on the scene, you see that this is the UI, and here I have the exchange script, which is the script that interests us, because here we get the balance using this function right here of this helper. We're not going to get deep into how PlayFab client does requests and everything, but basically here we're getting the user inventory, and on success we're calling, well, we get the virtual currency, and as you see here, we use the PlayFab server simulator instance, the currency code that we just filled. So we get the coins, and then we trigger this event that on exchange listens to it. I know it seems kind of complicated, but it's the way to do it with PlayFab. And when we get the balance, here we just use it to fill the UI. It's here the crystal balance label. and we show it. So that's how we get the crystals UI. But if we go now on our game, we see that there's no crystals here. We added some currency on PlayFab, and then we went here and added the code, but there's no currency. So what we need to do is go back to PlayFab. So we added this crystal currency to our title, but not to our player inventory. So to do that, go to players, search. This is our player, we just logged in. And under virtual currency and crystals, we will be able to add some of these crystals to us. So I will add, for example, 500, save. And if I now go to Unity and open, here I have my new crystal balance. So that's nice. We did that on Exchange. So that's perfect. In a real cases scenario, this would be happening when, for example, we kill a monster. We would triggering a PlayStream event, and then through Azure functions, we will be adding this new crystal balance to our player. And this will be very, very easy with the new Moralis and PlayFab integration. And you'll see we'll be doing videos of this very, very soon. Keep tuned, guys. Perfect. So now that we have the crystals, we can actually trade some. So I'm going to trade, for example, if we go to the exchange, let's go to exchange for a second. As you see here on top, this is the change, okay? So it's 1 septim for 50 crystals. And this is handled here on crystal input value. Every time we change this input value, this is what's happening. And we're basically doing the exchange and checking if we have enough crystal balance and everything. So if we have, for example, if I do 600, I won't be able, of course, but if I do 200, yes. So I'm going to trade, and you'll see what happens here. So I have my MetaMask, and a message is popping in my MetaMask, okay? So if we go to game state machine, we now see we are not in shopping state, we're now in transacting state, okay? And under transactions, I'm into the exchange transaction. So I'm going to confirm now. And transaction is successful. But as we see this message here, crystal subtraction failed. This is because we need to go to PlayFab again. And I missed this, sorry guys. We need to go to settings here, title settings. And make sure that under API features, here, we need to allow the client to subtract virtual currency, okay? So again, this won't be happening when we integrate fully Moralis to PlayFab, because we'll be doing this through PlayStream events and Azure functions. But for now, we use this, we're doing this for the client, and also it is just a demo. So save. And if we try again now, let's try this again. I'm gonna buy 300. Let me open my MetaMask first before clicking trade. Okay, so trading now. Confirming message. And now, yes, we have septim, and also we have subtracted 300 crystals. So if I open the menu, I tried this before, so I have more septim, but now we have just 200 crystals and 12 septim. So we can now stop this and go to the exchange transaction, which is the script that took care of this trade, and we're basically calling Moralis execute contract function, passing the game contract address that we just filled, as you remember here, this one, right? And the ABI, and we're calling the add septim. So if we go to Visual Studio where we have the contracts, we're calling this function right here. We're calling the add septim, of the game contract, which is calling the septim contract here. And we're basically we're minting new tokens to the player wallet address. So this is how it works, okay? And if we go back to Unity, if we go to transacting, okay, if you remember, we passed to shopping to transacting state. We have the transactions here, right? So this is the one that we just did. But if we open, we'll see that this works similar to the shopping state, okay? So on enable, it checks at what current shop we are in. And if we are, for example, right now in the exchange, we are calling this function, the function right here that we saw, and we'll be seeing now the same for the outfit. But as you see, this is the one that we just called, okay? We just called this. Okay, so that's it for the exchange shop, and this is how we trade some Web2 currency on PlayFab to ERC20 tokens. All right, so the same process will happen if we now reach the outfit shop instead of the exchange shop. So now, if we go here, we passed from exploring state to in-shop area state, but now the game manager, the game state machine, sorry, knows that we are in the outfit shop. So if we now press enter, we will be opening the outfit shop instead of the exchange. So this is the script that interests us. If you open it, I'll just set some debug points so we can see what's happening here. So I'm going to press E. And as you see, first we get the septim balance because now we have some. So what happens is, let's go here. What happens is that because now we have some septim minted through Moralis, we can get the token balances using these magic functions right here. So passing our wallet address that we get here, and the current chain, we get the tokens by passing the septim contract address that we added on our singleton smart contracts. So this way we can get the ERC20 token balances. Then we try to get the user inventory. So what's this? What we're doing here is we're trying to get inventory items from PlayFab. So as you see, we use this PlayFab client IPA and get user inventory, and on success, we try to get every item. And then if we got some items, we will contrast with catalog. But I think now we don't have any. So this will stop here. And as you see, we don't have any items. So what we need to do is add some items to PlayFab. All right, so we are in PlayFab. And to add some items to our user, what we need to do first is create a catalog for the title. So if we go to economy, create new catalog, I'm going to call this outfit shop catalog, save catalog. And here we have our first item automatically created. So if we go back to Unity, under assets, project, outfit metadata, I prepared some metadata for you guys that I created using my IPFS uploader version 2, which you can see here in this video. But to go faster, you just can copy this, and I saved you some time. So I have here the green outfit. And what we're gonna do is go to the first item. We're gonna set the item ID as 0. We don't need display name. We're keeping this simple. On the description, I'm gonna paste the IPFS URL, and then I'm gonna copy the IPFS URL, paste it right here. Now copy it and paste it under custom data. So I do this because in Unity we could just get the description, and then using a Unity web request we could get this JSON data, but we're keeping this simple, so having the JSON in the custom data is it will be enough for this video. And also we want to have the full IPFS URL, because we're gonna pass this as a token URL when minting the outfit. So we need both, right? We need the JSON and the full URL. So I think that's it. Save the item. And now do the same. So do the 1 and 2 using, not this, sorry, using the red outfit and the yellow outfit URLs. All right, so I added the 2 more items. You see with each URL here. And now if we go to Unity and we go back to the NFT Outfit shop, we should be getting the items. But hey, no, it's true. We don't have the items because now we just added the items to the title catalog. And it's the same with the currency before. We need to add these items to the player inventory. So go to players, search here, click on our user, and under inventory, we can grant some items here. So select item, and as you see, we can grant the items that we just added to the catalog. So I'm granting the item 0, item 1, and item 2. Perfect. And now, yes, if I go back to Unity and open the shop, I should be getting those items. Nice. And as you see, it has a price, right? So if we go back to PlayFab and see those items, you'll see that in custom data, there's a price value, which I added with IPFS Uploader version 2 that can add attributes to metadata. And that's very nice because these price are the ones that I'll be now checking in order to be to know if I have enough septim balance or not to buy this. But before doing so, go to Outfit Shop again and let's see how we retrieve these items from PlayFab. So basically here now, yes, with the result, we had some items in the inventory. And for each item, we're calling this function, contrast with catalog, and you'll see why. We're passing the inventory item that we are retrieving. And here, first of all, we're using the catalog name that we haven't filled. So here on Singletons, PlayFab Server Simulator, we should have filled the catalog name, which is Outfit Shop catalog, I think. But if you don't do it, it doesn't matter because what this does is getting the default catalog, which is this one. So there's actually no problem if you don't fill that. And then we're using this PlayFab client IPA method, which is get the catalog items. Okay, so it's important to differentiate between the catalog items and the items from the catalog that are in the player inventory. Because there's some data that it's only on the catalog items, and there's some data that there's only on the player inventory items. But we need to have both. So that's why we contrast it with the catalog items to get both. So that's what we're doing here. We're deserializing the custom data. Okay, that this is the JSON from the metadata URL, and we get the metadata object. And then if we have attributes, which we have because we have the price, we go here in the shop inventory and we populate the shop item. If you go here on Unity, on Outfit Shop, you'll see that we have this shop inventory, right? Outfit Shop has this shop inventory right here, which is basically a grid, and we're populating shop items, okay, with this icon and then the price label and everything. So this is what we're doing right here. Populating the shop item, passing the item instance. This item instance is the player, the inventory item on the item in the player inventory, which has the item instance ID. And this is unique ID. We will use it for minting the NFT. Then we pass the metadata object, okay, all the attributes and name description. And here, the catalog item description is the full metadata URL, right? If you go back to here, this is the description, right? The full metadata of IPFS, and this is the custom data that we converted to metadata object. So this is all that shop inventory needs. So if we go to shop inventory to this method right here, we'll see that we are adding a new shop item. And if we go to shop item right here on init, right? So shop item is this, right? If we go to scene, this is the shop item. And this shop item has this on-click handler right here that will trigger an event called onSelected. And this event onSelected, it's important because it will be listened for the outfit shop, okay? Then we will call this on shop item selected handler, okay? And here we will save this, game manager will listen to this event that we will trigger, and we will save that item, okay? That item will be saved in game manager, on game state machine, sorry. And we will know what item we want to make a transaction on. So now we can go back to the game, open your MetaMask, and you'll see what happened, right? What will happen is that transacting state will be activating when we click this, and the outfit transaction is the one that will be activating too. So let's click on, for example, the yellow one. In MetaMask, the message is popping up. I'm confirming, and transaction successful. Nice. If we now open the outfit transaction, which is the one that took care of this, we can see that we've been calling the same function as we did before, Moralis execute contract function, but in this case, we've been calling buy outfit. So if we go to Visual Studio and go to game contract, buy outfit right here, first gets the septim balance, and we have this require to check if we have enough septim. If not, we cannot mint the outfit, right? The septim balance needs to be higher or equal to the outfit price. And then we call this function inside the outfit, which is buy. And this function, you see that it's just a simple mint to the origin, which is the player wallet address. And then also we remove the septim according to the price of the outfit, and remove septim also, as you can see, it's calling this function inside septim, removing the balance, right? Burning some amount of septim. So that's how this works. But also, just want to show you that when we went to transacting a state, right? When we passed from here, from shopping, right, to transacting, we have activated this. And just want to show you this, like before. We've just enabled. We knew that from the game state machine, we knew that we were on this time on the shop type outfit, and we basically activated the outfit transaction script, and we called buy outfit, right? Like this, what we just seen now. Okay, so that's how we mint some NFT outfits using ERC20. All right, guys, so we're almost done with this, but now for me, it's the coolest part, which is applying what we just bought to the character, right? Applying the new outfit that we just bought. So this will be happening on the menu. When I open the menu, I will populate the purchased outfits, and by clicking on them, I will be able to apply it. So on the menu, I just also set some debug points so you can see what's happening. I'm going to open it by clicking on M. And also we're getting the balance, right? We're getting the crystal balance and also the septim balance like we did on the other shops. But the important part here is that we use the player inventory to load purchased outfits. So let's continue. We are inside the player inventory. And here we're using some Moralis magic, okay? Because we have minted these outfits as NFTs, we can get so using the get NFTs for contract from this Moralis Web3 API, well, the SDK, and using our, this time, this outfit contract address that, if you remember, we set on the smart contract singleton, and also the current chain, which is Cronos. So if we pass, we'll see that we have one, okay? And each one, so you'll see these NFT owners, right? It has the metadata, the yellow outfit, nice. It has also the token ID and the token URL. So that looks good. And finally, if we have some, which it looks, we will populate it here. We will populate the player item, passing the metadata object and the token ID. And here we will instantiate the new player item. So if we finish this, what we see is that here, nice, we have this. So we are in the menu. We have menu has this player inventory, which is very similar to the shop inventory, as you see. And inside the inventory grid, we have this player item. Nice. So now comes the fun part. If we open this player item, this one has an on-click handler, also similar to the shop item. And this onSelected is listened by the player. Okay, the player. And the player, when that happens, well, let me show you. The player is around here, it's just here, okay? So we have the player right here. And the player, let's open it, listens to this and calls a method inside the outfit player outfit controller, which is just change outfit, passing, right, the texture that we got from the player item. And if we go to this change outfit, it's very, very easy. We have the skin mesh renderer and we change the new texture, the texture from that's coming from the NFT. It's gonna go right here, you'll see. This player outfit controller has the skin mesh renderer right here, which has this material, which now it's the default one, right? It's this default one. But if I now hit on the yellow, we'll be passing this NFT image, bam, to the player. As you see, here we have the new outfit. And now I am wearing the NFT outfit. I hope you guys enjoyed this one. Also, I can open again. Let's stop this. I can open again the menu and go back to default, which is just getting the, oops, like this, which is just getting, again, the default texture. Because if we open the player, sorry, the outfit controller, player outfit controller, you see when we awake, we save the default texture. So when we click on this item right here. Sorry, let's go to the menu. When we click on the default item, right, we finally call this method and return to the default texture. All right, guys, so I hope you like this one. I really enjoyed it doing it. And this was like a big deal for me because I really wanted to bring some value and some of my insights in what I think that it's important with new Web3 gaming and where we can integrate Web2 and Web3 gaming. So where Web3 is really bringing some value. So imagine that this outfit, we got it from, we've been spending a lot of time killing monsters. So now we can get this item that we can sell here, and maybe we can even sell it outside of the game. All right, guys, so that's it. No more talk for today. Let me know in the comments if you like it, and see you on the next one. Bye-bye.